Hi, my name is Alexander Brang. In this video, I'll be giving you a brief overview of TissueGnostics, what we do best, in particular, contextual tissue cytometry using AI for immunophenotyping and quantifying the tumor microenvironment in situ. TissueGnostics is 18 years old in 2021. We have an international footprint and have publications, scientific publications coming from 59 countries. In total, we have 1,649 reference publications in January 2021. We have an international footprint with our headquarters in Vienna, and we have international offices in Romania, United States, and in China. So just going into the product lines here, the StratoFax is a compact 2-slide brightfield scanner, very easy to use and very small footprint. The TissueFax product line are these three systems you see here. They're highly modular and flexible systems. They come in many different configurations. The first is the TissueFax Plus. This is an upright configuration, it's capable of scanning brightfield and immunofluorescence on an 8-slide stage. The same goes for the inverted configuration, but it's also capable of scanning well plates. The high-end configuration is the slide loading confocal, or the SLQ system, capable of scanning up to 120 slides in bright field, wide field fluorescence, and confocal fluorescence using a confocal spinning disk. These systems can also be combined with a liquid crystal tunable filter for multispectral scanning and spectral unmixing. The machine learning and deep learning solutions are two powerful new features in our image analysis suite. The deep learning nuclear segmentation algorithm is particularly well suited for dense tissue microenvironments such as in immune organs. As you can see here, these cells are extremely dense and almost impossible to tell apart from each other. But our nuclear segmentation based on deep learning does a fantastic job segmenting these nuclei with no user input. And this tool, combined with the machine learning based tissue classifier, makes for an extremely powerful combination. This tissue classifier is not limited by any number of tissue classes, and you can easily transfer your knowledge onto this into this model by brushstrokes and painting and color coding different tissue classes, as you can see here in this bone sample. So going into phenotypic characterization of tissue infiltrating leukocytes, this is a fluorescence, a 4-channel fluorescence of a colon sample. We have DAPI in blue, CD4, CD8, and FOXP3 in green. Our first step here is segmenting the nuclei using our classical nuclear segmentation algorithm. You can see that with those green lines encircling each nucleus. Each nucleus corresponds to a dot in these scattergrams. Just like in flow cytometry, we measure the expression levels of each channel within the bounds of each nucleus. So we can draw gates around nuclei, and we can see those nuclei within these gates encircled with red lines in the image. And we can measure the CD4 positive cells, the CD8 positive cells, and now we can find double positive cell populations such as the CD4 FOXP3 double positives here, using a gate and multiple input channels. We can use the same method for analyzing the tumor microenvironment and spatial phenotyping, except in this case we're doing spectral unmixing autofluorescence from this 7-channel immunofluorescence in this colon sample. Here we have each individual channel spectrally unmixed, and now we're using these scattergrams just like before to measure the expression levels for each of these 6 channels on the single cell level. StratoQuest can also be used to detect multicellular structures, such as the epithelial tumor, in this case the cytokeratin marker. We can detect these multicellular structures and also generate proximity areas to detect cells that come into certain proximities of the tumor microenvironment. In particular, an infiltration can be detected. We can use spatial phenotyping in colon cancer to find PD-L1 positive, CD4 negative, PD-1 negative, CD8 negative, and CD68 negative cells using input chaining and input gating in scattergrams. As you can see, we're taking one population of cells, this PD-L1 positive cells, moving them into a new scattergram, finding the lower left quadrant here, and measuring them in this scattergram for those very specific cell populations. In conclusion, TissueFacts cytometry supports researchers to move from image to data and with the aim to increase observer independence and reproducibility. Thank you for your attention, and I hope to talk to you soon.